All right, so let's pick up where we left last time. Here, we were about to discuss this part, right? It's about displacement and distance. So what we have here, the straight line distance between an object, straight point, and its end point together with the direction. Just pay attention to the words written in different colors. All right. So
Okay.
here we say that the straight line, it's a straight line already. Distance between an object's starting point and its end point together with the direction. So this is called as a displacement. That means we are interested in just the starts and the end. It doesn't matter what is the path of the movement object, but why we need to pay attention is just this distance. That's what we call the displacement. So the length of the path along which the object moves is the distance. That is what is the difference between the two. So all the path traveled by the object, it's called distance, or the measurement of the path is this distance. But from the beginning to the end directly is what we call displacement.
Okay.
Now, displacement is a vector. Yeah, it's a vector. Since it has a direction associated with it, distance is a scalar. So, again, let's remind what's the difference between a scalar and a vector quantity. We say that displacement is a vector because of what? Because displacement has two things. What are those two things?
Direction and
direction, yeah.
Distance.
It's not distance, we say magnitude. All right.
All right.
But for distance, we say it is a scalar because it has just a magnitude. So, distance and displacement are both measured in meter and SI units, as it has seen before. So, if an object moves in a circle after one complete rotation, the displacement will be 0 because we just ended with the same point that we started from. And the distance traveled will equal the circumference for sure of this circle. Okay, some mathematics here. If an object is displaced in two perpendicular steps, the magnitude of the displacement can be calculated using Pythagoras theorem, and the direction can be calculated using trigonometry for sure. So we all know what are those functions. Calculating them from this right angle triangle, we are interested in this angle theta. So the adjacent of this theta is this side, the hypotenuse of the triangle is this side for sure, and the opposite, that's what is this angle C, it's the opposite. So to calculate the sine, the cosine, and tangents, we are just use this or those formulas. All right.
All right.
I just mentioned this quickly, so we can go to move to the applications. The Pythagoras theorem for sure says that the hypotenuse squared equal the sum of the opposite square plus the adjacent square. So a square plus b square would be c c squared. Now here, a bus travels 500 meters east to 50 meters north, 500 meters east, and to 50 meters south. Let's try.
1,000 meters east.
What was that?
The displacement is 1,000 meters east, but the distance is 1,500.
So how did you come with this answer?
The distance is so 500 plus 250 plus 500 plus 250, which is 1,500.
What?
But the displacement is how much you go in one direction, basically. So it went 500 meters east, then it went 250 meters north, then 500 meters east, then 250 meters south. But then because it went south, it canceled out the north.
Exactly. So displacement would be just 1,000. That's what you say.
Right.
All right. Displacement 1,000 and distance is 1,500. All right. Now, yeah, we have this situation here. We have a climber climbs 50 meters up a vertical cliff face before being forced to climb back down 5 meters so that she can find an alternative route to the top of the cliff. So she climbs sideways to the left 2 meters, then continues to climb 55 meters to the top. The question A is what distance has the climber traveled? Again, we can just draw the situation here. This is the ground, and firstly she went up for 50 meters, and after that, before being forced to climb back down, that means after she reached this point 50 meters high, she came back for 5 meters. Now after that she climbed sideways left. Let's say she's climbed for this distance 10 meters. Then continued climbing, climb 55 meters to the top. Again 55 meters to the top. Now what is this? What's the distance has the climber traveled? It's again, we need to add all the distance traveled. That means what? What do you think? We're talking distance now.
Yeah. So the distance is
what's the method already? We need to add what? Isn't it 50 plus 5 plus
120
plus 10 plus 55? Yeah, maybe you're doing it directly, but I also need what the method followed to find that. How did you come up with the question is also interesting. So this is what you say?
120
meters. So 55, 1, 5, 10. This is correct. What about the displacement now? That's quite more difficult from compared to this one. What can we say?
So the displacement was...
That means that the displacements, what we mean by displacements is the distance between the beginning...
150.
100?
And 15.
And 15. So again, how did you come with this answer? Explain to me, please. It's not that easy to calculate the displacement for this situation. Oh, okay. So let's presume, or let's say that the displacement is this distance. All right, here, here. The displacement actually is what is joining between these two positions. It's always between the beginning and the end, all right?
All right.
So we can just draw this line. That's what forms the displacement. We are interested in calculating this distance here. So how could we do this? We just need to configure or identify some shapes here. We can translate this this part to this area. So what is the measurement of this part? It's parallel and equal to this part. That means this is a 10 meter. Okay.
Okay.
Now this side, if we measure it, we can find we have here 50 meter plus what? Plus 55. That means in total
So 105.
is what?
105.
105 meters. Isn't that shape remind you of something? I mean this shape here, here, and here, and here. What do you think? Isn't it a triangle with a right angle?
Yes, with a right angle.
So what can we apply here as a theorem?
The Pythagoras
theorem, exactly.
So
Let's name this. It's
and 5 squared.
Repeat again, please.
It's 105 squared plus 10 squared.
Plus 10 squared, exactly. That would be equal what? Let's name this one C. It's equal to C squared.
Yeah. So
for C, how much would be? It's a square root of this addition.
Yeah.
15 square plus 10 square. And finally, we can just plug in those numbers into our calculator to find finally what is the final result. Square plus 10 square, which is 100. Yeah. That will be just all right. So it's a 105 meter. 105 meter. This is the direction or the magnitude of I mean the magnitude of the displacement, I mean. Okay.
Okay.
And if we want to calculate for sure what is the direction, we can just count on this angle, the theta, and use one of the trigonometric functions, either cosine or the sine or even the tangent of this theta. Let's proceed just like this. We can just use the cosine. What is the cosine of this angle? As a formula, what do we know? How do we calculate the cosine of a certain angle? It's the adjacent divided by what?
Adjacent
divided by
the opposite.
It's not opposite. It's the hypotenuse.
Hypotenuse.
Hypotenuse, exactly. So, how much is the adjacent here? I mean, here we have 105. It's going to give just like 1. Adjacent here is 105 divided by 105. That's equal to 1. but that means we need to pick all the numbers here. I just calculate the approximately a value here, so it's going to give us theta is 0, and this is not correct because there is a movement to the left side along 10 meters. So let's try with the sign and see if it's going to give more convenient value here. The sign of the theta is the opposite. It's 10 meter divided by the hypotenuse is 105. If we divide 10 by 105, all right, that's giving 0.095. So this is the sign of the theta. Calculating the theta means applying sine -1 or arc sine -1 of this value here. So this is giving approximately 5.47 degrees. This angle is approximately 5.47 degrees. Okay. Now we are done with this question here. Any question here about the?
No.
All right. So can I clear or erase all of this?
Yes.
Right here, just to keep my space clear and light. So what is the magnitude size of her final displacement measured from here starting point? We just calculated, we found it's 105 meters. That's what we found before moving to this one. Now the next question say what? An object is displaced by 60 meters at the bearing of 60 degrees. If the object then moved 30 meters due north, what is the final magnitude of displacement of the object from its origin? The question here is what? The question is what is the final magnitude of displacement? We are again looking for the displacements, I mean, here.
Yeah.
So what can we do here? We again need to just to draw the situation to make it more clearer. All right. So can you propose any of the methods? Any idea?
No.
Okay, we can proceed. Just 1 second, I will just fix something here. Okay, so to find the magnitude of displacements after we have here two movements, we need to use a vector, for sure, vector addition to combine the two displacements here. We have two movements, that means we need to take in consideration two movements. All right. So what do we have firstly? So the step one, we can decompose the situation to many steps. The step one is to decompose the first displacement. What do we have? We have the object first moves what? It moves 60 meters bearing the 60 meters bearing of at bearing of 60 degrees. So to break this into a component, we can just identify two components here. It's the eastward and the northward components. So we have here, we can just make it like this. The eastward here, we have here 60 degrees and the distance is 60 meters. Let's name this x and this one y. The two components are this distance and this distance. So let's name it this east or components. That would be equal to what? This is the adjacent of this angle. That means we can just write 60 as a distance times the cosine of this 60 degree. Okay?
Okay.
And for sure the northward component, that would be the sine, for sure. So the northward components, that would be 60 times the sine of 60 degrees. Because of what? Because we have this measurement, or this distance is exactly the opposite compared to this angle. Now, if we calculate this 60 times cosine of 60, what is it? The cosine of 60 is 0.5. It's just 1/2. That means it's 60 times 0.5. So this is just 30 meter. What is the sine of 60 now? And just use our calculator. The sine of 60. This is 0.866 times 60. This is giving 50, around 52, 51. Let's just write 51 points. This is 9 meters. All right.
Okay.
So this is 30 and this is 51.9 meter. Actually, it must be just like this because this is bigger than this one. But it doesn't matter. Now, what do we need to do? Actually, we have to add the second displacement. What is the second displacement? If we look at this second part here, what do we have? If the object then moved 30 meters due to where? North, right? This is the second, right. The second movement for us. So the new northward component is just the sum of the two northward displacements. what do we have first here? Northward was measuring 51.9. Now we need to add this to what is given here. Let's name it as new northward. That would be just 30 plus 51.9. That is giving what? It's 81.9 meters. Is that correct for you?
Yes.
Now what do we need to do? We need to calculate the resultant displacement for sure using the Pythagorean theorem. Now firstly, let's try to draw this the final position of the objects. That would be just like this, with this line is 81.9 and this one is just 30. What we looking for is the hypotenuse here. Isn't that like a triangle with a right angle here? Can you see this one?
Yes.
So what can we say? What can we do if we name this hypotenuse as before c? C squared would be what as a value?
C squared equals
this
A
side
squared plus B squared.
Yeah, this is the formula, but if I want to write directly the values here, this is 81.9 squared, right?
All right.
Plus 30 squared. That means the C for me would be the square root of this results. It's 81.9 squared plus 30 squared. Calculator will do the job for us. Okay, this is gonna give as a result 87 points. This is 87 points, the 82 or 22. What is that? On the calculator is giving, yeah, it's 28 meter. Did you get this formula, this question?
No.
Not really?
No.
All right, so let's try to repeat what we have done here. The question is decomposed to two data. The first thing says that, what did we name that? It's just an object, okay? An object is moved at this angle, 60 degrees. All right?
All right.
It's traveled 60 meters at this angle. After that, it just went north, due to north, with a distance of 30 meters. All right?
Okay.
The question is to calculate the measurement of the displacement again. Measurement of the displacement, that means the magnitude of the displacement. Let's try to just draw it straight way. The initial and the final position of our object. This is the one what we look for, which is drawn in red color. We need to just measure what is this distance, okay?
Okay.
So the first step, as I said before, we're going to be interested in this. Let's name this one the x, and this one adjust y. To calculate this too, we need to calculate what we named before the eastward components and the northward components. If you pay attention here, we can identify what we call a triangle with this right angle here. All right.
All right.
So directly we can just write the x is just what? What is this side is representing to this angle? Is it the adjacent or the opposite? The x for the 60 degrees. Is it touching it or just looking at it? This side for this angle.
It's touching it.
It's touching it. That means we need to use the cosine because it's touching it. So what do we write? Actually, let's do it in details. If I'm asking you, if I'm dividing this x by this 60, what is this giving for me? If I'm dividing the adjacent by the hypotenuse, as we have seen before here, if you do remember, we looked at all of this last time. Distance adjacent to the angle divided by the hypotenuse. What is given? What is that?
Cosine.
The cosine. That means I can do the same here. I have the adjacent divided by the hypotenuse. That's giving the cosine of 60. So what I'm looking for is this x. I just can multiply by 60 the both sides here. That's giving cosine of 60. So the cosine of 60, it's obvious, it's just 1/2. So 1/2 times 60 is just 30. I'm measuring distances, so it means it must expressed in meters. I hope this one is clear for you.
Yes.
Now let's move to the y. What is y? It's this distance, which means equal to this distance. This is my y. I'm now interested in calculating the northward component now. So if I'm dividing this distance, sorry, I need to put the y divided by 60. It's just like I'm dividing the opposite by the hypotenuse. What is given as a trigonometrical function? Isn't it the sine of the 60 degree?
Yes.
Let's move back to what is given. Distance opposite now, it's not adjacent, it's opposite opposite the angle divided by the hypotenuse is given the sine. So that's what I have done exactly here. That means if I want to calculate my y here, that would be multiplying the both sides by 60, giving the sine, the 60 times the sine of 60 degrees. As I see it here, without just typing again in the calculator, it will be given 51.9 meters. So this is measuring 51.9 meters, and this x is measuring 30 meters. Okay.
Okay.
Is that make sense for you now?
Yes.
Now the second step is just knowing what is the measurement of this red line. If you pay attention closely here, we can identify this triangle here to here to here. Isn't that a triangle with this right angle here?
Yes.
So again, we can use the same theorem. We can find the length of this red line. The theorem is called for sure a Pythagorean theorem. So what can you say about the length of this side here? From here to here is just 51.9. From here to here is 30. What is the total now? Can you add these two numbers and give me the results? 30 and 51.9.
No.
30 plus 51.9. The total is just 81.9.
Yeah, 81.9
meter. This side is already given as 30 meter. So because this is a right angle triangle, the Pythagorean theorem says that if I'm naming this side as C, I can write again the C square equal the A square, which is this one. Let's name this one as A and this one as B. So it's A square plus B square. That's giving the 30 square plus 81.9 square. So to get rid of this square here, I can just plug in the square roots. Square root of C square, that would be giving the C. This is the square root of the 30 square plus 81.9 square. The final results will give the length or the measurement of this displacement. I've already calculated as this one. It was 87 point. This is 87. Point 28 meter. That means this C is measuring 87.28 meter. Is that making sense for you now?
Yes.
All right. Okay. Now the next one say what? Here we have a box is dropped from an aeroplane 2000 meter high, traveling horizontally at 100 meter per second. This is the speed. The box takes 20.2 seconds to hit the ground. While the box speed up vertically, it continues at 100 meter per second horizontally. So what distance has the box traveled horizontally when it hits the ground? So let's read again just to understand very well what is unknown here, what they are asking for here. We say that an airplane is dropping a box. Okay, dropped from an aeroplane 2000 meter height. So here, this is the ground, this is 2000 height meter, traveling horizontally at 100 meter per second. So the speed here is 100 meter per second. Now the box takes 20.2 seconds to hit the ground. So to come to the ground here, it takes the delta t as 20.2 seconds. So while the box speeds up vertically, it continues at 100 meters per second horizontally. Now what is the distance? What distance has the box traveled horizontally when it hits the ground? That means we need to know what is the distance traveled here horizontally. Any ideas about this one? Just let you a few seconds to think about it. So what can you say? Any idea about this one? I can't hear you if you're speaking. I can't hear you. I do see you that you are talking, but I can't hear you. Maybe you have muted your mic. Not yet. Not yet.
Can you hear me?
Yeah. Now, yeah.
My computer is about to die. Can I get a charger?
Say again?
My computer is about to die. Can I get a charger?
Yeah, you can go and get your charger, so we cannot interrupt this one. For sure.
Okay, I'm back.
All right. So we were talking about we need to find what is the horizontally distance traveled by this box. We said that is dropped from an aeroplane at an altitude or a height of 2,000 meters. Now, what is the horizontal distance traveled by this box before it hitting the ground? We have many data here. The time taken just to come to the ground and the speed. That means we need to use the notion of speed here. How do we define speed in general? It's distance divided by what? By time, right?
Right.
So it's taken 20.2 seconds and the speed was 100 meters per second. So from this equation, we can just get what is the distance. All of this is vertically. The d would be v times delta t. Just plug in the values here. The d would be 100 times 20, the time taken, 0.2. That would be 100, that would be 22 and 0 meter. This is 2020. This distance is 20 meter. Okay?
Okay.
So we can't come back to this exercise because we don't have much time to complete it due to other engagements. We will come back to this to the same question before proceeding to the rest of it. All right.
All right.
So see you next time.
Okay. Bye.
Bye bye.